You know that feeling when your computer has a super powerful processor, but it just feels slow? Well, chances are the real culprit isn't your CPU at all, it's your storage. So today, we're going to figure out the true speed of your disk and why it's probably the biggest performance bottleneck you've got. So, your system feels sluggish. What do? You probably run a quick speed test you found online, right? And the numbers look amazing, but it still doesn't feel fast. The problem is, a lot of those common methods for testing your storage speed, they're just plain wrong. They are not telling you the real story. All right, so here's the game plan. We'll kick things off with why we even need a true benchmark in the first place. Then we'll quickly cover what disk I/O actually is. After that, I'll introduce you to the pro-level tool for the job, VO. We'll walk through 3 essential tests you should be running, and finally, we'll talk about a super common mistake, the DD pitfall, that almost everyone makes. Okay, let's dive right in. So, why are we so obsessed with a standardized tool? Well, it's simple. You need a single objective benchmark. I mean, think about it. Are you trying to compare file systems like ext4 versus NTFS? Or maybe you're trying to figure out why your home NAS is so slow. You need a single, reliable test to get real, comparable data. It's the only way. But before we even touch the tool, we got to get on the same page about one key term that's at the heart of all this: disk I/O. So disk I/O, it's really just all the talking back and forth between your computer's brain, that's the CPU and RAM, and its long-term memory, your hard drive or SSD. And here's the kicker. Your storage is physically way slower than your processor. That communication, that I/O, is almost always the biggest bottleneck. It's what makes a system with a blazing fast CPU feel just frustratingly slow. And it really just boils down to 2 things. You've got input, which is reading. Think of that as your computer grabbing data from the disk, like when you open an app. Then you have output, which is writing. That's when your system saves data to the disk, like when you save a document. That's it. Benchmarking is just measuring how fast those 2 things can happen. All right, so the big question is, how do we actually measure this stuff accurately? It's time to meet the hero of our story. This is the tool that's going to give us the real, honest answers. FIO. It stands for Flexible I/O Tester, and trust me, this is what the pros use. And this is where we see the main showdown. On one side, you've got FIO. It's built specifically to test the actual physical hardware, your SSD, your hard drive. But on the other side, you've got the common culprit, DD. And here's the problem. DD often ends up testing your computer's super fast RAM, not the disk itself, and that's not what we want at all. And right here, this is the secret sauce. This one little flag, -direct equals 1, is what makes FIO so incredibly powerful. What it does is it tells the system, hey, ignore the memory cache, just completely bypass it and go straight to the disk. This is how you get the true, raw, unvarnished speed of your actual drive. Okay, enough theory, let's get practical. We're going to walk through 3 absolutely essential benchmarks that show you how your disk performs in the most common real-world scenarios. First up on the list, sequential write speed. The best way to think about this is, imagine you're saving a huge file all in one go, like you're exporting a big video project or creating a full system backup. That's what we're testing here. The goal here is simple. We want to measure raw throughput. So when you run this test and get the results, the number you're looking for is labeled BW for bandwidth. That's going to tell you exactly how many megabytes per second your drive can actually write. And here's the command you'll use. Take a look. See that -RW flag? We've set it to write. And notice the block size, BS equals 1M. We're using a big 1 megabyte block size because that's what best simulates writing a single large file. Okay, next up, we're going to do the exact opposite, sequential read speed. This time, we're testing how fast your drive can read that same kind of large file back. Think about opening that big video file, or maybe restoring your system from that backup you just made. And check this out. This is what's so cool about FIO. The command is almost exactly the same. Literally, the only thing we changed is that RW flag. We just flipped it from write to read. That's it. All right, now for the big one. Honestly, this might just be the most important test of all, because this one simulates how snappy your computer actually feels day to day. We're talking about launching apps, browsing through your files, just general multitasking. Now for this test, we're not looking at bandwidth anymore. Forget that. We're hunting for a different number called IOPS. That stands for I/O operations per second. A high IOPS number is what makes your operating system and your apps feel quick and responsive. Why? Because they're constantly reading and writing tons of tiny little files scattered all over your disk. So, take a look at the command here and you'll see a few key changes. First, the block size BS is now a tiny 4K to mimic those small file reads and writes. We've also bumped up the num jobs to simulate multitasking. And finally, the RW flag is set to rand RW because we want a realistic mix of random reading and writing. Okay, so now you know the right way to test your disk. But we absolutely have to talk about the wrong way. We have to address that tool you see recommended all over the internet and explain exactly why you should never, ever use it for benchmarking. So here's the big problem with the DD command. By default, it doesn't write to your disk. It writes to your computer's super fast system memory, the cache. So your command prompt immediately tells you done and shows you this unbelievably high speed. But in the background, your operating system is still slowly trickling that data from RAM onto the actual physical disk. It's a complete illusion. So the key takeaway here is pretty simple, and this quote on the screen just nails it. DD is a great tool for copying data. It's perfect for that, but it is absolutely not a benchmarking tool. If you want a serious, accurate performance test, you just have to use FIO, period. So there you have it. You've got the tool, you've got the knowledge. You now know how to find the real speed of your storage. So the only question left is, what bottlenecks are hiding in your system just waiting for you to find them?